Hello there. In this video we are going to look how this reference works in Java. So the keyword this is a special reference which references the current object. This means inside the class member function, if you want to refer the object, the present object, then we can refer that using the keyword this. So there are instances where we need to refer the current object when we are executing the code inside a constructor or inside the member function of a class. So here in this video we will see some examples that will tell you how this can be used in multiple situations. So we will see the examples one by one. First we will see how we will use this reference to differentiate the parameter with the internal member. So here is the code snippet. The class name is number. It has a member, a constructor, and a method to show the result. In the constructor, if you see, there is a parameter, and parameter name is the number. The type is integer. And the internal member also the number. Here the name is same, the parameter name as well as the internal member name, both are same. So the parameter, the number, is in stack. The internal member, the number, is in heap. Our goal is inside the constructor, we want to copy the data from stack to heap location. The stack location is identified by the name, the number. Heap location also identified by the name, the number. So inside the constructor, it will not be possible to write a statement like this. The number equal to the number. If we do so, the compiler doesn't understand which location to refer, because the left hand side also the number, right hand side also the number. So it may end up assigning the parameter to a parameter. So to differentiate the location heap with the stack, here in the left hand side we use the keyword called this. So here this represents the stack, the heap of the current class. So we are landed into the constructor and we are executing the instruction inside the constructor. When we specify this, this object is like the class is saying it's me, kind of me dot the number or the current object. So to differentiate this name to the location, we use the keyword this in the constructor. You can see that in line 8, and we are having a initialization. Once we specify this dot the number, then compiler rightly understands that it needs to copy the data from parameter to internal member. In other words, it needs to copy the data from stack represented by the number, which is on the right hand side, to the location in the heap represented by the number. I mean the variable the number. So this keyword helps that it's the destination location of the copy is the heap. Here in the main, we are creating the instance of this number. We are supplying a value of 10. Then we are making call to the add method. Then we are making call to show result. Let's see how it works in Eclipse. So here is our number class. In the number class, we defined the internal member. Then there is a constructor as well as a method called add. So in the main, we are creating the number instance, and after that we are adding it. I mean, we are making a call to add method. Finally, we are making call to show result. So this show result function will print the number. There is a add method and a constructor. Here if you see, the first usage of this is here. So it's already explained in the slide. I'll keep a breakpoint here. And in the main, if you see, the error is gone. If you need, we can put a breakpoint here as well. So first we are making call to the constructor. So here, if you see, the number represents 10. Here it is an uninitialized value. After that, this will get initialized. And in the variable window, we can see here also it shows this. That means it represents the execution is staying here in the last statement, and this represents the current object, and the number is initialized to 10. So we are calling this dot the number. That means when the execution stays inside here, it represents this current object. So this number represents the number inside the heap of this current object. All right. So S1 we cannot refer. So once we are outside the class, we can reach to that heap location through S1. But when we are inside the heap, we don't have a reference to represent the current object. So that's why we use these references. So Java provides this reference, and we use that to represent the current object. All right. Let's continue executing it. It makes a call to add number. Here, if you see, here's the second usage. The number add is returned here. We will see that in more detail later. So the show result will print 15 here. So the second use of this reference is to call the constructor. Suppose if you want to call a constructor from inside the class itself, then we can use this reference. We know that constructor is like a function. So when we overload a constructor, and if you want to call one constructor from another one, we can use this reference. Let's see an example. Here there is a class called car. It has two members, max speed, car name. In the constructor, we are having two parameters. One is speed and another one is car. And through those parameters, we are initializing the internal members. If you see in the first statement, max speed is initialized with the speed, which is the incoming parameter. Since the parameter and the internal member name is different, we doesn't use any this reference here. But in the second parameter, the parameter name, car name, is matching with the internal member, car name. So to differentiate this, we use the keyword this dot car name equal to car name. That means the copy is from stack to heap. In some situation, you may need to copy the content from the heap to stack also. That time, the keyword this will come on the right hand side of the equal to. Here you see there are next two version of constructor. In the first constructor, user may be giving the speed as well as a car name when they are constructing the car. But in other two versions, they can give either one of this. That means they can create a car with only speed, or they can create a car with only name. But as a class designer, we want to initialize both the member, whether they call the constructor with only speed or with only name. So if they call it with only speed, then we make a call to our base constructor, which runs from 8 to 12. And in the first version of, in the speed version of a constructor, we supply the speed parameter to the existing constructor, and name we are supplying it with a blank. So here we use this. So here this open parenthesis, then we pass the two parameter. One is incoming one speed, and another one we are forming it on the fly. So this initializes the speed with whatever is coming as parameter. Then name is initialized with a empty string. And the second version, the user is giving the car name. So in this case, we are once again calling the base constructor here, which takes two parameters. First parameter, we are supplying it as 150. That means we are giving a default speed for a car when user constructs a car with just name. The second parameter, we are passing it to the constructor, which is an incoming parameter for the third version of constructor, which runs from 20 to 23. So this is the second usage of this keyword. Here this keyword represents the constructor. So Java constructor does not allow, Java does not allow calling the constructor by its name. Here, if you look at the code snippet 15 to 18, for example, Instead of this, we cannot use car here. We cannot use a statement like car, open parenthesis, speed, comma, double quote. So Java will give you an error stating that it will look for a function called car, and it will state that there is no function named car is defined inside this class. So this is the notation to call the constructor. We have to use this keyword, then we can start supplying the parameters. So here we are calling other version of constructor inside the constructor. So then we have a print method in this class. This will just print the car name as well as maximum speed. In the main method, if you see, first the user is creating a class with two parameters. So this will land up in the first version of the constructor. Then we are printing it. Then we are testing our other two constructors. Second time we are creating a car with just name, and third time we are creating a car with speed. Alright, we will see this in Eclipse. So here is our car class, two internal member and a constructor. If you see we are reusing the constructor here. This keyword and two parameter will end up and calling this constructor. Finally, we are printing the data. Alright, let me remove this breakpoint here and add one here. So here is the first version of constructor. If we land up here, it will go to our first version of constructor and initializes the internal members. Then we are printing the result. It prints the car name is Skoda and the maximum scale is 250. This time the constructor is calling only the constructor with only the car name. So when we get inside, we will get inside the correct version of constructor because of the overloader constructor. Let us jump in, because we are at the current line is at this, and if you see, it will make a call to our existing constructor. So it will initializes that, then prints the result. We will jump in again, one more step in, and if you see, it calls the constructor. So this is the second use of this keyword, and you can see the result here in the bottom. Okay, let us talk with the third usage of this reference. This reference can be used to return the current object to its caller. Here if you see, these are all the methods, member methods for the number class. So we are going to add that and test that in Eclipse. All three members return type is the number class. So the methods are for number class and it returns the number class instance itself. So the add method, we know that this number class has only one internal member. So the add method increments the number with positive value. The subtract method will performs a subtract operation, and the multiply function will perform the multiply operation with the internal member x. And if you see, all three member returns number to the caller, I mean the current instance to the caller. Here in the void main, we can create a instance, and then we can call the method. Then we can use the return value to call the additional method. So in the command, if you see, we are ultimately performing the operation like a plus b into c. So at line 18, we are actually constructing the object, and the object will have initialize its internal member to 10. So this 10 is actually considered as a. Then at line 19, if you see, we are calling our first method s2.add, and we are passing a number 5 to it. So now this will perform the operation a plus b. Since we know that add of 5 will return a number instance, so we are making next call to the method multiply in the same line. So add of 5 method call will return an object, and that object is number. That's why we are once again calling the multiply. So when we return this object from the method add sub multiply, it will make the statement like what you are seeing in at line 19 is possible. So a method returns a current instance, and from that method return type we are making call to the other member method. So here first we call the add, and from its return value we change it with multiply. So this statement performs the expression a plus b into c. Let's explore this in Eclipse. And we will make call to those two new methods added. So we landed up into the number instance. If I step in, if you can see the only available member, the number is initialized in the first statement, which we can consider it as a. This a. Then we are making call to our add method. So I am stepping into it. If you see, the add method is called, it increments the number. We know that the member is already initialized with 10, and when we are adding it, it will have a value of 15. Now when we are returning this, we are returning this object, right? So the object is already have a member initialized with a 10 and then added with a 5. So the number at present it is holding 15. So since we are returning this current number, when it goes to the caller, it is the result of a plus b. So now when I make a call to multiply, I am stepping in, and the number will hold the value of 15. So now we are performing the multiplication there. So this makes the expression a plus b into c possible when we are return the same object from the method. So when we want to return the same object or the current object, we need to use the keyword this. So this is the third usage of keyword this. And now let us print the result. The number is 90. So that's all here in this video. Thanks for watching. See you in your next video. Bye.